Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. For the factoring, you're going to start by removing the 2 and multiplying it by the 5. And so you're going to have x squared minus 3x minus 10. Whenever you go to factor, you're going to use negative 5 and positive 2. So you're going to have 2x minus 5, and then 2x plus 2. This first will not factor, but the second set will, so we'll have x plus 1 instead of a 2x plus 2. And so this would be the answer for your factoring. For the math knowledge question, what value of x makes it true? Well, we're just going to solve for x. So we're going to distribute across the parentheses, and we'll have 3x minus 18 plus x equals 30. Combine your like terms, so 4x minus 18 equals 30. And then add the 18, so you have 4x equals 48. And if you divide by 4, x is going to equal 12. And so your answer would be B. Okay, so we are looking at lesson 83 today. We're looking at vector addition. So hopefully after this lesson you'll understand how vector addition works. We're going to look at the parallelogram method first. It's a method where you add 2 vectors by drawing a parallelogram using the vectors as 2 of the consecutive sides. So we're going to take our vectors and we're going to make a parallelogram with the vectors. The sum is going to be the vector that's along the diagonal of the parallelogram. So the sum of the 2 vectors is going to be the diagonal that's your parallelogram. So we have vector v here, and we have vector w, and then we're just going to take these 2 sides and recreate them, because remember, a parallelogram, these 2 sides are congruent and parallel. These 2 sides are congruent and parallel. And then the sum of the vectors is this diagonal here. And so that's what we're going to do for the parallelogram method. So we're going to use the parallelogram method to add the 2 vectors. Again, y'all can use the little bitty graphs up at the front, or y'all can go get some graph paper from by the filing cabinet on the back. Either one is fine with me. So we always start from the origin when we graph these. So we're going to go 1, negative 3. So I'm going to go over 1, and then I go down 3. And so my vector is going to look like this. And so this is vector S. And then vector T, I'm going to go over 5, and then I'm going to go up 4. And so this is going to be vector P. Now that you have your 2 vectors drawn, we need to create the other sides of our parallelogram. And so basically, this vector was 5, 4. We went over 5 and up 4. We can start at this point here, and we can go over 5 and up 4. And so now it's parallel and the same length as the vector that we just had. And so there's that side. And then we can do the same thing from this one. We can go over 1 and down 3. And so that would be the 4 sides of our parallelogram. Now the sum, the result of the 2 vectors, is the diagonal from the origin. And so the diagonal is going to come over to this vertex here. I'm going to do it in a different color so you can see it. That blue line is vector S plus vector T. And so we went over 1, 2, 3, 4, 5, 6, and up 1. So our result is 6, 1. So that's how you would do the parallelogram method. The head to tail method is a method where you add 2 vectors by placing the tail of the second vector on the head of the first vector. So you put the heads to the tails. The sum is the vector that's drawn from the tail of the first vector to the head of the second vector. Now, the head to tail method can be used for more than 2 vectors. You can use it for as many vectors as you would like. But the parallelogram method you can only use if you have 2 vectors. You can't use it if you have more than 2, because you can't make a parallelogram with 6 sides. That's not a parallelogram anymore. So you can only do the parallelogram method if you have 2 vectors. So this would be a picture of the head to tail method. We have 1 vector here, and then we have 1 vector here. So we put the head to the tail, and then we start at the tail of the first vector, and we go all the way to the head of the second vector. And this one right here would be the sum of the 2. If we had another vector, we could put it here and then draw it however it was, and then the sum would be from here to here. So you can use the head to tail method for any number of vectors that you have. So we're going to add these 3 vectors using the head to tail method. So you start at the origin. And so we're going to start at the origin, and then we're going to go over 3 and up 2. And so this is vector A. Then you start from this point right here, and we go left 1 because it's a negative 1, and then up 2. And so this is vector B. Okay, and then we go from this point left 4, and we didn't go up or down any because it's a 0 for the y component. And so this part is vector C. Okay, so we have vector A, and then vector B, and then vector C. And you can actually do them in any order. You don't have to do them A, B, C. You can do them in any order, and you'll still get the same answer. The final vector, we go back to where we started, which was at the origin, and we connect it to where we ended the head of the final vector that we had. And so this black is the sum of vector A plus vector B plus vector C. Okay? And so we go left 2 and then up 4. So the sum is -2, 4. And so that would be your answer. So that's how you use the head to tail method. Now we're going to add the vectors m and n, and we're going to find the magnitude and the direction of the resultant vector. So the resultant vector is what you get when you add the 2 together. So we're going to use trig for this one. And so I'm just going to do a rough sketch of it. Vector m is 0, 4. So that means that we just go up 4. And vector n is 5, 0. So that means that we went to the right 5. Okay? And so I am going to take vector m and move it right there. And I'm going to make the resultant vector, which is the hypotenuse here. And this is a right angle because we had a horizontal line and then a vertical line. And so we can find the magnitude here, and we can find the direction. So the magnitude is the length of this. Well, this length here is 5, and this length here is 4. So we're going to have 5 squared plus 4 squared equals your hypotenuse squared. So 5 squared is 25, 4 squared is 16. So if you add those together, you get 41. And then you can take the square root of those. And so your magnitude is the square root of 41, which you can round to 6.40, or you can leave it as the square root of 41. It didn't specify, so it doesn't really matter to me which one you do. Now the direction, that is talking about this angle here with theta. So the way that we're going to find that theta is to use the 4 and the 5 and the tangent ratio. So the tangent of theta is opposite over adjacent, so 4 over 5. Now remember, to solve for theta, we're going to do tangent inverse of 4 over 5. And so if you plug that into your calculator, you should get 38.66. So the magnitude, either this one, 6.40, or this one, those are the magnitudes. And then this one, 38.66, is the direction. Okay, so you can do either one for the magnitude, and then the direction is this angle right here. Okay? So looking at this one, a plane is flowing a horizontal distance that can be represented by the vector 7,000, 0, and a vertical distance that can be represented by the vector 0, 3,000, where the magnitude of both vectors is measured in meters. What is the magnitude of the distance that it has traveled? So the distance is going to be found by finding the length of that segment. And so that is the hypotenuse. And so the way we can find our hypotenuse, we can say 7,000 squared plus 3,000 squared equals the hypotenuse squared. And so if you solve for the hypotenuse, you should get 7,615.77 meters. And so that would be the magnitude of the distance it traveled. Okay, so now we're going to look at some practice problems. So I want you to try the parallelogram method to add the vectors, and then y'all unpause the video and I'll go over it for you. So we're going to start at the origin. We're going to go over 3, and then up 4. So that's vector x. And then we're going to go over 4 and up 1. And that's vector y. Okay. So now, once we have these two pieces drawn in, remember we go to the head and we repeat each vector. So I'm going to go over 3 now and up 4. And then I'm going to start here and I'm going to go over 4. And then I'm going to go up 1. And so that makes your vector. And then the sum of them, you start at the origin and you go diagonally to where they meet, which is right here. And so we go over 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3, 4, 5. So the sum is going to be 7, 5. So that would be using the parallelogram method. Looking at this next one, we want to add the vectors using the head to tail method. So we're going to start, I'll start with A. Again, you can start with any of them. The order that you do them doesn't matter. We're going to go over 1 and then up 2. So this is vector A. And then we're going to go from here, right 4, and then down 5. And so if you connect these, this is vector B. And then from vector B, we're going to do vector C. So we're going to go left 1 and then up 7. And so that would be those 3 head to tail. So now what we need to do, we go back to the origin and we go to the head of the last vector that we ended with. And so that puts us here. And so the black is the resultant vector. And so we went over 4 and up 4. So if you add those together, you should get 4, 4. Okay? We're going to look at another one. We're going to use trig to find the magnitude and the direction of the resultant vector. So again, we're going to start by drawing just a rough sketch. We're going to go over 3, and then we're going to go down 2. So this length here is 3, and this length here is a 2. I know we went down 2, but when you're measuring length, it's going to be a positive 2, not a negative 2. Okay? So we're going to start off by finding the hypotenuse. We're going to use Pythagorean theorem. 3 squared plus 2 squared equals h squared. So that'd be 9 plus 4 equals h squared. So that's 13. And if you take the square root, you get the square root of 13, which is approximately 3.6. So you can put either one of those. Both of them are acceptable. Okay? Now that's the magnitude. For the direction, we first need to find this angle. And so we're going to do the tangent of theta is opposite over adjacent, so 2 over 3. And then tangent inverse of 2 over 3 will give us theta. And so our theta value is 33.70. Okay. Now, the direction, you always measure the direction starting from the positive x-axis and going counterclockwise. And so what I'm drawing in red is the actual direction that we need to find. So on the example, I'm going to go back to it. We were in the first quadrant, and so when we went this direction, our angle was just our theta, because that's how much we went to get to our vector. But if you look at this practice problem, our angle is given by the red, and then we found that the theta was 33.7. So on this one, if we subtract 33.7 from 360, that'll give us our direction. And so it'll be 326.30. So that would be your theta. Now, I'm going to go over a couple that are not in the first or fourth quadrant. I'm going to do the second quadrant and the third, just so that you can see how they work. We did this last year when we were dealing with changing from rectangular to polar. We would have the R and the U, and then we would have a number at 140 degrees or something. We dealt with those last year. This is the same concept, so if you remember that, that's kind of what this is going towards. So I drew my triangle that I have, and let's say that this angle here is 30 degrees. Well, we always start from the positive x-axis and we go this way. And so the red is our angle. Well, we know that if we had gotten all the way here, that would be 180 degrees, because that's a straight line. So this part of it is 30, so that means that our angle direction is 150 degrees. Okay, and then looking here in the third quadrant, let's say that this was a 40-degree angle. Well, our angle, we always start the positive x and go around, and we keep going until we get to our vector, which is here. And so this part is 180 degrees, and then we went another 40. And so the total, we would say 180 plus 40, this would be 220. So that's how that works. If y'all need to, you can go back and re-watch that, re-listen to it. But it's different depending on which quadrant you're in. Okay. Looking at another one, we have a plane that's traveled 2,000 meters east. So that's going this direction. And then it climbed a height of 3,000. Let's go in that direction. So this height is 3,000, and the bottom part here is 2,000. And we want to find the magnitude in the direction, the magnitude that gives the total distance, which is here. It says to write the vectors that represents these two translations. So if we go this direction, that would be 2,000 0 because we didn't go up any. And then when we used this one, we only went up. So we didn't go left or right any. We only went up 3,000. So those are your two vectors. And now to find your hypotenuse, you're just going to use Pythagorean theorem. And so if you solve for your h, you should get 3,605.55 meters. Okay, and so that would be the answer for the magnitude that gives total distance the plane traveled. Okay, looking at the challenge question. Y'all tried this one, and then after y'all have tried it, you can unpause the video and I'll go over the correct answer for you. So it told us that C is the result of A and B. So when we use the parallelogram method, that means that this is the diagonal. C is our diagonal. So I'm going to go ahead and do my A. We go over 3. And so this is vector A. And then I know that the diagonal ends at 5, 6. So that's the diagonal. So I've got a parallelogram where one of the sides is right here. I know that I've got a side here because it's parallel and the same length as vector A, so it's 3. And then I've got the other side that's right here. And so vector B is just what is this side length here. So let's go over 2 and then up 6. So using the parallelogram method, I'm going to get 2, 6. Okay? Using the head to tail method, we're going to start by drawing A, and we went over 3. So that's vector A. And then for vector B, we don't know what we did, but we know that for the final result, I'm going to do it in black. We went from 0, 0 up to 5, 6. And so that black one is the final. And so B has to connect from here up to here. And so we go over 1, 2, and then up 6. And so we should get 2, 6, which is the same thing as what we got for A. You should get the same answer using the parallelogram method as you did using the head to tail method. Okay, so your homework is 1 through 30 from problem set 83. So make sure that y'all do that tonight so that we can go over any questions you have tomorrow.